Alright, today we talked about graphing quadratics in class, and we had one example of how to graph a quadratic. This is not the quadratic we graphed in class, we had a quadratic. We figured out how to graph it, and I want to just go through again how did we do each of those, and then maybe get you started on a couple of your homework problems. So, when you graph a quadratic, well, first of all, if you don't know how to graph something, you always can just make a table. So you could sit here and make a table and go, okay, what's x, what's y, and you could do that on this one. You go, okay, x is 0, y is -3, x is 1, y is 1, minus 2, minus 3, -4, and you can go through and do that and get all the points. What I want to do is get us, first talk about the important things that we care about on this graph, and then be able to graph those things. Okay. First important thing when you graph a quadratic is the y-intercept. We always care about a y-intercept because there always is a y-intercept. How do you find a y-intercept? You plug in x equals 0 and see what you get. So on this problem, I'm going to plug in x equals 0, and I'm going to get y equals 0 squared minus 2 times 0 minus 3, y equals -3. So I have a y-intercept of -3. Done. Got that on there. The next things that I care about are the x-intercepts. In my x-intercepts, you plug in y equals 0, which for this case means that we get 0 equals x squared minus 2x minus 3. Solve. Well, now, this just looks like any other quadratic equation that we've ever solved. So we can solve, so we can factor, we can use a quadratic formula, whatever. So I'm going to factor this one, x minus 3, x plus 1, which gives me roots of 3 and -y. X-intercepts are the same word as roots, are the same thing as solutions. All these things mean the same thing. X-intercepts, roots, solution, whatever. Here are the two x-intercepts. I have an x-intercept at 3, and I have an x-intercept at -1. So I care about both of those things. There's one other thing that I care about. Well, two, but it kind of goes into one. I care about the vertex of this thing. As we saw in class today, whenever we graph one of these, we get a parabola. The vertex is that lowest point, or if it's going the other way, the highest point. So we want the vertex. We said in class today, you get the x-coordinate of the vertex, you do -b over 2a. So I'm going to go ahead and do that for this problem. -b over 2a. -2 is +2. 2 over 2 times 1 is 2. Equals 1. The x-coordinate of the vertex is 1. Now I gotta figure out what the y-coordinate is. Well, how do I figure out the y-coordinate? Well, I go like this. Y equals 1 squared. I just plug it into the equation. 1 squared is 1, minus 2 minus 3. Y equals 1 minus 2 is -1, minus 3 is -4. So the y-coordinate is -4. So my vertex is at 1, -4. Come over here, 1, -4. The last thing that goes along with the vertex is the axis of symmetry. And all the axis of symmetry is just the line x equals -b over 2a, which in this case we just found that is x equals -2, 1, I'm sorry. All that means is I have this imaginary line that goes right through here. And it means I have the same thing on both sides, so I can actually put in a point right here. I know that has to be on there because it's axis symmetry. Just reflect that over. These are already reflected over, and I can make my graph. And I've graphed that parabola. I knew the x-intercept, the y-intercept, the vertex, and the axis of symmetry. Y-intercept, x-intercepts, vertex, axis of symmetry. Okay. I'm now going to look at a couple of your homework problems, at least one or two, and see if I can get the answers to those. So I'm looking at page 436, 5 through 10. 436, 5 through 10. Okay, match each graph with its function. So what we're going to do is take each of those and figure it out. So I'm going to look at A first. A is the line y, or the parabola y equals x squared minus 2x. Here's all I'm going to do. I'm going to figure out what are the x-intercepts, what is the y-intercept, and what is the vertex, and I should be able to graph this thing after that. Okay. If I want the y-intercept, plotting in x equals 0, that just means that y equals 0. So it has an x-intercept, or has a y-intercept of 0, 0. X-intercepts, you set y equal to 0. So you get 0 equals x squared minus 2x. Factor x times x minus 2. So you get x equals 0 or x equals 2. So you have x-intercepts of 0 and 2. Then the vertex is negative b, negative 2 over 2a, which is 2 over 2, which is 1. Okay, so this thing has to have a y-intercept at 0, x-intercept at 0 and 2, and a vertex at 1. Let's see if we can find it from this. Alright, I want a y-intercept of 0, so that could be 5, that could be 7, that could be 9, or that could be 10. I need to have x-intercepts at 0 and 2, so that takes that one out, that takes that one out, and it only gives me these two answers, 9 and 10. Those are the only two with x-intercepts of 0 and 2 and a y-intercept of 0. The vertex has to be at 1. We saw that. Let's find out the y-coordinate of the vertex, because these both have vertexes at 1. So let's just figure out which one we want. So I'm going to go back. I'm going to plug 1 into the equation. Y equals 1 squared minus 2 times 1. So that equals negative 1. So it has to have a vertex at 1, negative 1, which is number 9. So all that means is that 9 went with graph A. So 9 is A. Something you'll notice on 10, since that's going down, that should just be the opposite of the one we just did. So if we could find the opposite of the one we just did, we'd be done with that one. Let's look at one more. Let's look at graph B and figure out what that one would be. X squared plus 2x. Okay, real quickly. Y-intercept, 0. X-intercept, that's x times x plus 2. So your x-intercepts are 0, negative 2. Vertex, negative 2 over 2 times 1, which is negative 1. I can find out actually what is the y-coordinate too if I put in negative 1. That'll give me negative 1 squared plus 2 times negative 1. That's 1 minus 2, which is negative 1. So it has a vertex of negative 1, negative 1. So let's go through and see if we can't find this thing. Y-intercept is 0, x-intercept is 0, negative 2, vertex at negative 1, negative 1. Okay. It needs to have a 0 y-intercept. So it could be that one, or this one. It needs to have an x-intercept of 0 and an x-intercept of negative 2. So it can't be 10. It ends up having to be 5 or 7. Those both have x-intercepts of 0, negative 2, and y-intercept of 0. It needs to have a vertex of negative 1, negative 1. Negative 1, negative 1 is 5. So 5 goes with B. Now I've got 2 of them done. 5 is B, 9 is A. And you can figure out the other C, D, E, and F on your own.